Hello, students and viewers all over the world, my fellow learners, my fellow students that have been learning chemistry from this YouTube channel. I am bringing up the types of adsorption isotherm using the Brownian classification. You must have seen types of adsorption isotherm coming out as type 1 to type 5. I will be explaining what each of them mean, and many students shy away from this area because they do not understand what each of the adsorption isotherm mean, and also many cram this isotherm because it is cheaply seen in the examination, and then they do not know what each adsorption isotherm stands for. Okay, so you actually do not need to cram. At the end of this video, you will be glad you did. Okay, watch the video now. The adsorption isotherms are shown here. You have adsorption isotherm 1, 2, 3, 4, and 5. So let's explain. Let me talk about adsorption isotherm 1. Actually, it is the adsorption isotherm that explains adsorption of gas molecules to the adsorbent, okay, having micropores such as activated carbon, okay. This kind of adsorption isotherm deals with microporous adsorbent. That means the pore size, the pore diameter of the adsorbent used in this type of adsorption isotherm will be the one that is the size will be microporous. I will be coming to that later. Okay, example of an adsorption isotherm here will be adsorption of a gas, for example, hydrogen and nitrogen gas on activated carbon. Okay, because most time activated carbon, okay, of this micropore size can go for this adsorption isotherm 1. Okay, that is an example. Now I come to adsorption isotherm 2. It actually represents a monolayer multilayer adsorption. Okay, a monolayer versus the multilayer adsorption. The beginning of the almost linear middle section. If you look at this place, I call it the almost linear middle section of the isotherm. Is often taken to indicate the stage at which the monolayer coverage is complete and multilayer adsorption about to begin. So kindly understand that, okay? And then in the type 2 adsorption isotherm, it explains the non-porous or macroporous adsorbent. That means most time when you use adsorbent that are macroporous in size, okay, you may be bound to have this type of adsorption isotherm. Okay, I go to adsorption isotherm 3. In adsorption isotherm 3, it is obtained when the interaction between the adsorbent and adsorbate, okay, are weak. When the interactions between the adsorbent and the adsorbate are weak, that is when you have this kind of adsorption isotherm. So the information about monolayer coverage or formation cannot be provided with this type of adsorption isotherm. I hope you understand my explanation. Okay, if you do, I go to adsorption isotherm 4. In adsorption isotherm 4, this actually explains the variation of is a variation of adsorption isotherm type 2. If you look at it, it almost have the same thing you have here. Okay, but just that it continues. okay? It's a variation of type 2, but with a finite multilayer formation corresponding to complete filling of the capillaries, okay? So type 4 adsorption isotherms are actually given by mesoporous adsorbent, okay? So as I explained, it represents it is a variation of type 2, okay, but has a finite multilayer formation, okay, as I have earlier explained. So type 4 adsorption isotherms, they are given by mesoporous adsorbent, okay. I mean, when you use a mesoporous adsorbent, okay, you may be bound to have this kind of adsorption isotherm. The example of an adsorption experiment where this can occur is adsorption of water vapor, okay? Adsorption of water vapor on activated carbon at a particular temperature, like 30 degrees C, okay? You may have this kind of, okay, isotherm coming out, okay? And so type 5 adsorption isotherm, it has a similar variation with the type 3. You can see where the type 3 ended is like type 5 continues from there, okay? So it is obtained when water vapor is adsorbed on activated carbon, like at about 100 degrees C. That is an example you can obtain for a type 5 adsorption isotherm. Actually, it is used for the adsorbent used here is usually weak, okay? It's a mesoporous adsorbent with weak interaction, okay? The adsorbent used in obtaining this kind of isotherm is it usually bring about weak interaction. I hope you understand what I mean by that, okay? I will be explaining. I just mentioned some words here. You heard about macroporous, you heard about microporous, you heard about mesoporous. I want to give a better explanation for you. Look at this. So if we talk about type 1 adsorption isotherm, I said the adsorbent medium you can use there is microporous. That means the pore diameter, okay, the pore size, okay, of the solid must be around this size, must be less than 2 nanometer. That will give you a microporous size, or 2 nanometer is equivalent to 20 Armstrong, okay? So, but if the pore range is between 2 to 50 nanometer, you will be obtaining a mesoporous, okay? A mesoporous. This is not supposed to be. This is supposed to be greater than, okay? Greater than, okay? Let me rewrite it so that you have it greater than 50 nanometer, okay? When the pore size is greater than 50 nanometer, you will be having a microporous adsorbent, okay? But a situation where the pore size is between 2 and 50 nanometer, you will be having a mesoporous, so between 2 to 50 nanometer, okay? And this is about 20 to 500 Armstrong, okay? So within this range, you will be having mesopores, okay? Whereas pores greater than 50 nanometer are called macropore, okay? So as I've told you, the adsorbent used here is microporous, here is macroporous or non-porous. Then here you use macroporous, but the challenge is that the bond form is with weak interaction. It's very weak, okay, between the adsorbent and the adsorbate. Meanwhile, here the adsorbent side is between 2 to 15 nanometer, and here the adsorbent side is also mesoporous, but the interaction between the adsorbent and the adsorbate is also very weak. I hope you have a better understanding right now of the adsorption isotherms 1 to 5. So if you do, I want you to just like the video, then you share with others, subscribe to my YouTube channel, and put on your notification button so that whenever I upload a new video, you will be duly notified. I am waiting for you to do that. Okay, thank you for doing that.